Right, thank you very much. And thank you all for the coming and returning after lunch and so on. So our panel today is around this topic, and to follow on from what Jeremy's just mentioned, the cultural difference. I would be interested in hearing from the panel about what your perception is regarding the cultural difference between IT-oriented cybersecurity and the people who look after it, and the OT world. Do you think that cultural difference is probably one of the problems, or just one of many problems that we have in these industries?
Right, well, I'll pick up the first answer there. From our perspective, we work in transport and we're very much operational. We work with the technicians that look after train servicing and install operational sort of hardware. And so we get to see frontline the sort of tensions and challenges between IT and OT. You know, who's looking after the Wi-Fi router in a depot? And I'd say that they're definitely different, evidently. But I think it's case and situation and day of the week dependent as well. With that, I'll pass on to the next person.
So I think it's related to what their objectives are on a day-to-day basis. So if you think of an IT perspective, it's about SAP and stuff like that. And if you lose SAP for a couple of days, then people don't get paid, and that's a bad thing. But for some people, losing SAP is maybe a good thing. Whereas in the OT environment, you could cause physical damage, structural damage, or even sadly kill people. So that's one aspect to it. And that's why there's an operational difference between IT and OT. But I think the other one is about timelines. So if you think in the IT environment, typically equipment's replaced every 3 to 5 years. We've all got laptops, which you get called in and say you need a new whatever. Whereas in the OT environment, we typically have equipment online doing its thing for 20 years. So what we end up with is a long legacy of equipment out there which was never built to be secure by design or even secure. So you've got that consideration to take into effect in that. How do you go about keeping the online system running for such a long period of time, whilst considering security, which has the view that it's ever changing and the threats are evolving all the time. So it's a perception of how you go about your day-to-day operation, really. I think makes that difference between the IT and OT environment.
Thank you.
I was going to say what Victor said, but systemically, we'll find that OT security is kind of a 30-year lag of reappropriating IT security controls.
Yeah.
So we're looking now at industry professionals basically saying, oh, focus on the perimeter, focus on the demilitarized zone, which is something that we were looking at in IT in the late 90s. And we're still following that trend of essentially every time that IT did something 30 odd years ago, we are now kind of looking at that now.
Really? Okay.
But at the same time, culturally, in an organizational capacity, it's also quite confusing if you look at organograms of organizations that operate this kind of technology. No one really owns it. It's always at a very strange level. So you'll have the CISO that is looking after the entirety of the enterprise IT systems. But then you'll find that for each individual site, you'll have a single individual manager that is looking after a very small piece of operational technology. And it's granular to the point of they don't have enough buying power or management buy-in to really have that much sway in what they want to enact. So there is that strange disparity in where the ownership is in the organization.
Yeah, I just want to touch on that. I think that's really true. I think part of the problem is an aspect of the theory, but also the assignment of responsibility and who is responsible for what. And a lot of OT people may not see IT security or cybersecurity as their responsibility. They're part of it, but it's not their responsibility. So I think responsibility or the sense of it is really interesting.
So where do we move on from that? Because there's the lag that's been mentioned, there's the responsibility, organizational responsibility, but also there's training involved in that, and training people are, and this is one of the perceptions I've seen with looking at the two sorts of sides of this coin, is that if you think of the people who are trained to look at security and the software engineering and the hardware engineering, they tend to come from more computing backgrounds, whereas this is of gross, right? Whereas if you look at who's looking after the OT systems, they tend to come from electrical or civil engineering backgrounds. Do you think there's a fundamental problem in where we start to educate the people to be able to reflect on the systems they build, not just from a performance perspective in terms of, you know, speed or optimality, but also in terms of security, resilience, verifiability, all those kinds of safety things?
So I think education is one route to being able to sort of have a more secure and safe system. But I think it's also about culture and identity.
Yeah.
If you graduate as a mechanical engineer, you think of yourself as a mechanical engineer or a physicist, like I was originally. And it's very hard then when you sort of give yourself a new identity to become a safety professional, a security professional. I mean, I've worked in safety for more than 25 years and cybersecurity in the past 5 to 7. And even I, who chose to come into cybersecurity, sometimes I still think of myself as safety. So it's the content of the courses. Do the syllabuses need to be looked at? And I know the Engineering Council looks at safety, security, risk and ethics. But it's also the professional identity, the job titles that people have, the people they hang out with and the skills they exchange.
So I think if we think of what's happened over the last 20 years, probably 20 or so years ago, we started with a safety culture in the OT environment. Then we thought about reliability culture, which actually dovetails perfectly into a safety culture. If you look at the top 10 aspects of what's required in a safety culture, actually they're the same for reliability.
Yeah.
And now we're thinking of security culture as being some nebulous thing, which is actually a black art almost. Actually, if you look at the requirements for a security culture, they dovetail perfectly into the safety and reliability culture. So actually, there's not so much of a step to bring this in as business as usual. So from my perspective, we need to get away from the idea of a cybersecurity specialist. So if you go to an OT site where we're at today, quite often someone's going to be designated as the point of contact for security. So what we need to be doing is saying, if you're an electrical engineer or control and instrumentation engineer or mechanical engineer or a process engineer, then an awareness of security has to be part of your business as usual. And that's where it really needs to get embedded, just like we've done in the past with safety and reliability.
Yeah, yeah, thank you.
I don't really have any suggestions for what you would do for training, but if you do look at the disparity between those two types of people, so you have an engineer, and when you look at how they consider security, they'll look at very deep technical things such as like the actual control logic within the PLC and that kind of thing and how that works.
Yeah.
Whereas if you take someone that has originally been a cybersecurity or IT consultant and then has transferred their skills to OT, they kind of hit a barrier where you start seeing things that's just like, oh, well, network segregation, that's what we want to do. And then they don't really go, they almost seem like the actual OT itself is a black box that is for the engineers and we don't touch that.
Yes.
Whereas we're getting into the era of secure PLC programming practices, and those people that are doing OT security need to recognize that they're doing OT security. And I think it's more of a case that the cybersecurity professionals need to start getting trained on more like vendor programming practices rather than necessarily focusing on the OT engineers being trained in cybersecurity. Because I think the cybersecurity concepts in that situation are a bit more trivial than the OT concepts from a cybersecurity perspective.
Completely agree. I had a bit of an epiphany during the week when someone was telling me that I thought latency was just a problem for control. And he said, no, it'll just short all the grid. And I went, oh, okay. Yeah. So, Wisey, go ahead.
I think if we look at our current and at least previous undergraduate degrees, I certainly don't remember cybersecurity as part of the electrical or electronic engineering course.
No.
And unless you partner up with computer science, which very few universities do, at least traditionally,
Yeah.
to have
Here-
joint engineering computer science course, security might still be an optional module, right?
Yeah.
And very few people in the OT world trained up in security at the basic level. And I think that might be a big issue as well.
Thank you. So I wanted to talk about the very nature of OT systems around this need for real-timeness, right? So the real-timeness, and does the fact that these systems have this real-time operation, how does this interact with the agility of being able to have some form of computer or human in the loop to be able to mitigate some of these problems, especially if it's happening live?
So we were talking about the aspect of time. 1 week is a long time or a short period of time, depending on the system you're looking at. And as humans, we can react, and we can react very quickly, but there is a limit to how quickly we can react. So you've got a synchronization issue. If you have a system that has to react faster than the human is able to analyze and pick up the information, then you have to consider one aspect of real-time OT design. But that's a kind of perfect world where you can design and hypothesize and program, and this is what's going to happen at this stage in the process plant. But then reality intervenes. And that's where the role of the human in the loop is so important. And we need to consider about the usability and operability of these real-time OT systems. Can someone interface with them? Can someone take control? Can someone modify, for example, a batch process? We have to recognize that we can plan for like the best and the worst when it comes to operations.
Thank you.
That's an interesting question, actually, because the actual point of action can be very quick, and that will always be beyond the control of an operator. If you're making that assumption that someone has already got to the point of command and control of the assets, so that's the assumption that's being made.
Yeah.
If someone has got command and control of your assets, you're in deep, deep trouble. So you've got to almost think of the processes that are in place. So failure is an event, is a process, not an event. So actually you need to think of how does the bad actor have to get to the point of command and control where you're effectively toast, because I can't see anything in the short term that's actually going to overcome that human factor interaction. The human factor interaction actually comes before that point where they can actually, in human time, potentially make corrective action, in my part.
Right. Okay, that's interesting. Thank you.
The potential real-time aspect of an event and the consequences is kind of why I'm really interested in OT security. So if something starts going wrong in the physical world, it's almost less predictable than an enterprise system, and physical things can cascade and go wrong in significant ways really quickly. And I always remember the first time when I started learning about response and recovery in OT, and it's not just the case of, oh, well, we'll start just going through these processes that you would do in IT. The processes are so far stretching. So, for example, if you've lost network connectivity over a large geographic range, how do you then deal with that? You then have to have third and second line types of communications in place, like radio and things. Mm-hmm. But in terms of the challenges with the real-time nature, it's knowing what is going wrong at the same time. So adversaries as well as defenders have this issue in an OT system of process comprehension, where knowing what is going wrong or how to cause things to go wrong is extremely difficult, because from a network perspective, you can scan, like say, a PLC, and you can notice that there are certain ports open, and you can say, right, well, it's running S7COM, it's running Modbus or whatever, and that's as far as you know. You don't know what it's doing in the physical world. You don't know what the control logic is doing. So it's really difficult from a defender's point of view specifically to know what actually is going wrong, because the physical sensors are telling you what they're telling you. You can't get any more info without actually physically seeing the thing with cameras or eyes. Yeah. So it's that real-timeness is then very panicking. The immediacy of the way that these can happen, like Jeremy said when he was keynoting, the people start panicking when things start going wrong, especially when there are physical things going wrong in front of you as well.
That's why we have to study the socio side, the reaction side.
Absolutely, 100%.
And the complete opposite, Wisey, what do you think about machine learning, AI?
I mean, I think, just coming back to that very quickly, then I'll answer. I think that when you have human in the loop, and you inevitably will for lots of applications, and it depends on what kind of loop, right? I think that what you have is effectively, when you just have machines, right, you have a fixed envelope of performance, and you can somewhat design for that envelope. When you have a human being, that envelope expands and dynamically changes, and that's really scary. So you have longitudinal behavioral change, and you have also temporary reactions and panic. And the physiological state of the human becomes part of that latency problem, and that's really scary. I think there's a lot of research already on not just machine learning with human in the loop, but an observationary machine learning to look at how can they try to calm the human being down, change the observational data to reduce the cognitive load and try to keep a baseline, right, of cognitive state. And I think, the applications we work on, like air traffic control, that's super stressful. And that's like a 15-minute window before you start losing your cool.
Very good. So that's a very a positive use of AI, not just to control the system, but also to help ease the users themselves. That's a very interesting example. Okay, so my next question is around the nature, the very features of an OT system. Would you say some of the inherent features would make it easier to be open to cyber attack, or do you think some of the inherent features of an OT system make it more difficult to detect?
So when we're talking about the features of an OT system, we can talk about a PLC, something that you can put on the desk in front of you. But you're also talking about an agglomeration of all the sort of systems connected together. And I think that we have to look at it in different levels, because that's the question that someone from the outside that doesn't have the background in the field is going to say, is this vulnerable to cyber attack? Give me a yes or no answer. Explain to me how. And if in order to explain how, you need to consider the levels. Are you talking systems of systems or individual? But I'd like to suggest also you should consider that system at 3 levels as well. People, plant, the hardware I've just talked about, and the software, and also the processes. Because in order to control a system, you have controls in all those 3 categories: the people, the training, the processes, the organizational structure, and then the technology itself. So I'm not giving you an answer to the question. I'm just asking that when you take a lens to look at through your real-time control of your OT system, consider small and large and apply the 3 levels of perspectives. And don't forget about the human in the loop.
So once again,
Sorry, go ahead.
thinking this about a little bit holistically, if you think of as I said, failures is a process, not an event. So within the operational technology environment, typically there's some form of segregation between the OT system in operation and the IT system. Now, I know we're making lots of connections these days to close that gap. So if you think of it logically then, the attackers have got to do 3 things to get to the endpoint, which is causing some damage. First one, they've got to get to an insider and compromise that insider. So that's point number 1. So that could be an operator of the plant or something, or a third party with third-party access, which is a growing threat vector, particularly after COVID, with people working from home and doing engineering. So if you went back 4 years ago, there was no way on this earth that if you'd gone to any operational plant and the engineer said, can I leave my desk, go to my home and make changes to the plant? It would have been no. Nowadays, that's not common practice, but it's not unusual. So that's the first point. So I would say over the last 4 years, we've probably made the problem worse in that respect, and compromising the insider. The second point then is you've got to compromise the network that all these PLCs and controllers are connected to. Now, within the IT environment, since we're making that comparison, there's scanners all over the place looking at what's happening in your network. Within the OT environment, scan is either non-existent currently or very, very poor. So the example that we at Schneider Electric bring to the party is that one of our systems was targeted in the Middle East. The hostile actor was on that network for over 2 years, undetected. And they made 3 changes to their attack software, which was very good programming, actually. They had 3 variations of their attack vector. So then the third one is then finally attacking the assets. So we've got 3 levels that they've got to go through to get within the OT environment to make an attack effective. So there's subtle, actually very clear differences between the IT and OT environment, but I think there are steps that we can make to make it more difficult to get to the final point of attack, which is the asset, through the insider, through the network, and then getting to the asset, which actually gives me some form of comfort that there's gaps that we can definitely close within technologies we've got available today.
I'm going to assume that we'll say that in terms of difficulty or ease of attack, we're going to assume that we've already got into the OT environment. And at that point, it's trivial to do basically budget cyber vandal style attacks, nuisance attacks of turning PLCs off or basically causing a little bit of havoc. It is exponentially more difficult than in an IT system to do something that's actually complex, and something that you would like, long-term process degradation or espionage is significantly harder. Going back to when I said about process comprehension, just coming from the network and having no human intelligence or no prior physical infiltration of the organization, it's extremely difficult to actually do any meaningful attacks in an OT environment. You're pretty much reserved to being essentially a cyber vandal. From a defensive point of view, it's also significantly more difficult. Programming control logic typically relies on using vendor-provided library functions and building them up in the ladder logic. And typically these are proprietary. You can't view inside them. You can't edit them. So when we're talking about PLC programming practices, specifically secure ones, you can't even apply these to the existing library functions because you don't have access to edit them. So that's, again, it's not just difficult, it's almost impossible for most feasible programming practices. But I think we're going to start seeing either those being open sourced or open source library functions actually come into existence on their own.
So as it moves towards an IT-oriented system,
Yeah.
it's becoming less tight, I suppose, yeah?
Yeah.
Thank you.
Just want to come in there.
Yeah, go for it.
To get to the end point, as you say, there's a lot of proprietary stuff out there. But where we're at today in control systems is that the protocols which are used to make the command in effect are actually open.
Yeah.
Right? So Modbus has been out there for many, many years. Everyone knows how Modbus works. It's doesn't have no authentication to it, no encryption to it. So if you get onto the network, and that's also the same for Ethernet IP or other DNP3, other protocols which are typically used, if you get onto the network, you can instantly make any changes to that protocol and have an effect without knowing anything about coding. So that's why it's extremely dangerous.
Mm-hmm.
And that can be done in a couple of days. So we worked with a previous organization myself. We built a PLC, went to a system integrator and said, build us this typical level loop control, and as you would normally build it by your design methods, which are approved. They shipped it to us, and within 1 week, we had 3 attacks which could be easily affected onto the PLC, either driving it into full drive mode, locking the system, and there was a third which I can't quite remember. So we need to, I don't disagree with my panelists, but actually you don't have to get to the point of making script changes to the endpoint. It's the bit in the middle where the vulnerability is.
Do you want to take it?
You designed that system. That's how you knew how to design the attacks for it. If you don't know, if the system is black box, if you've infiltrated it from the internet and you don't know prior information about that system, even though the protocols themselves may not have encryption on it, it's very difficult to discern what those protocols are saying is happening in the physical world. You don't know how they are, what they are sensing. You don't know what pumps or valves. Unless you have piping and instrumentation diagrams.
You don't have to know. Sorry, I disagree. You don't have to know. Industrial protocols are promiscuous. So if you get onto the network, you really don't need to know. A quick Wireshark will tell you all the IP addresses you need to know in the network, and you're toast.
Okay. Wisey, can you pick up?
Yeah,
I'd be interested to know it more for
I'll pick up
autonomous systems.
I think, yes, I think in the end, I think what you have is a skill set distribution matching problem, right? A knowledge matching distribution problem. In the sense that you might be interested in the bulk of attacks and the attack versus defense and how much knowledge they might require and skill sets and incentivizations. But you also might be interested in the most extremities. You know, the smartest attacker in the world may have so much knowledge, right? And then, you know, how you defend against that. I think for autonomous systems, it's worse in the sense that it's so real time. And you can do a very minor attack that offsets the balance or causes panic, that causes a cascade of crashes that have nothing really to do with the cyber attack, right? The attack was just a nuisance, but it causes cascade problems that are very difficult to imagine.
Yeah. We've got a real example of that, by the way. There was a DDoS attack on a UK power company, and they had a turnaround, and the firewall was originally set up okay with all the ports locked down, etc. But because of duress and the timing of having to get the power back on, they set the system up without closing back the firewall, because they opened the firewall up to allow third-party access. So this is a real example. The DDoS attack happened 2 weeks afterwards to hit the IT department. That went through the firewall, made a cascade effect, to your point, and completely destroyed an 11 kV switch.
There you go. Well, on the controversial conversation that we're having now, I think we'll open it to the floor. Thank you very much.
Thank you.
Any questions from the floor? We've got one person up there. And oh, sorry, we've one here, we've a couple here. May as well go shortest distance first.
Oh, that's the one that doesn't work.
It's not on. Oh, it's on. Hi. Hi, really fascinating panel. I love the OT, IT division clash and so on. I wanted to ask you about what's your take on the future of NIST regulations in the UK. So over the last few years, when it was being implemented here, we had this notion of prescriptive governance in the cyber assessment framework, where there were a couple of high-level principles that were fairly open to interpretation and a three-level risk management scale. So from what we spoke to engineers, they really struggle with this subjectivity and open-endedness of CAF, and actually they related it to the very kind of culturally grounded notion of engineers being they having prescriptive mindset. They like following standards, they like following rules, they don't like high-level principles, and they just really struggle with that kind of subjectivity versus objectivity, interpretation versus rule following. So I was wondering, going forward, how do you see the security regulations going? Where should they be going in your mind?
Well, Emma, do you want to take that? Yeah.
Well, I won't start to sort of speak for like the regulators. I must make that clear. So this is a personal observation. I think that the inherent sort of framework and like the kind of lack of clarity that like an engineer that wants a prescriptive solution might feel is actually a strength, because you can do a prescriptive complete solution for today's problem, but it'll be no good for tomorrow's situation. So we are, with the best will in the world, stuck with frameworks, and frameworks are optimized for this situation as well. I've just come from a European Rail Supply Association meeting where we were talking not only about NIS, but NIS 2. So this regulation isn't static, it is evolving, it's being broadened to more systems. And even if, like we're in the UK, we're looking at NIS and our interpretations going forward, our supply chain is European and global. So I'm afraid the engineers may have to work with standards and frameworks, and I speak as an engineer myself as well. There is no perfect hand-holding guide rail, so we can stop thinking.
I think frameworks are a really good thing, actually, as a former engineer.
I like a good framework too.
So why is that? Because it gives you some guidelines. Now, if you go through the process of setting your stall against the CAF, you can, because of and it's related to the business risk, and it all comes back to, if you think of it from a safety perspective, which I think people can understand, then you think of what's your tolerable risk. So you can quite rightly say that I'm running my plant, this is my tolerable risk, and these are the levels of protection or the mitigations that I'm going to put in place to meet that regulatory requirement. So you can have differences between assets who run in the same operational environment, but because they've got different tolerable risk levels, they can have different levels of protection. So that comes down to the engineering working with the management side to get that really good discussion about what's the business tolerable risk, what levels of mitigation do I have to put in place to meet the CAF requirements. So actually, that's why I think the framework's good in that respect, because you're given an objective of what the good, bad and the ugly is.
Thank you. Next question. Who's the next person? A couple over here.
Hi there. We've been talking a good deal about the sort of current perceived problems in OT. What do you see, there's been one reference to AI, what do you see sort of coming as as a future risk? We've been hearing a lot about things changing. How do you see that affecting OT?
Rick, do you want
Earlier this year, we saw GhostSec purport to have managed to do some sort of ransomware on what they said was a remote telemetry unit. It wasn't. It was a router that had some OT protocol capability. It was interesting though, because the idea that smaller cybercrime and hacktivist groups are deciding to develop or try and boast of some sort of capability in this sector means that we are now entering the age where we're seeing less advanced adversaries have the capability to start entering the sector and start causing problems. And with that, we're going to see a shift from the typical clandestine process degradation and espionage to more overt things like cyber extortion. And if we start seeing OT-specific ransomware and extortion, for example, these things are going to be a lot more difficult to deal with. So I think that's kind of the next thing, is the kind of like the cybercrime aspect in that sector.
Whitey?
I think that's triggered a lot of thinking. I think that in the future we might also see automation of cyber attacks.
Yeah.
You will see bots generating their own code and sharing knowledge of success and failure, and synchronizing that around the world and being extremely scalable in generation of attacks. That would be pretty scary, but I can't see why that would not be a possible scenario.
Yeah.
Yeah. Thank you. We've one here.
We've got 2 minutes left.
Yeah.
So you talked about the difference in culture between the IT and the OT departments. So we are seeing that infrastructures are increasingly getting connected, like electricity and transportation, or electricity and gas networks. So how do you think the difference in culture across organizations will impact security? And do you know of any real world incidents where difference in culture across organizations has led to a cyber attack?
So I've worked across 3 sectors in 30 years, between sort of aerospace and oil and gas, energy, and now transport. And each time you change sectors, you can very much see a difference, leaving aside cybersecurity, across the whole mindset, across the whole culture. Again, it's that tribal point I made earlier. So when you talk about an interconnected system where you've got transportation connected to power, those differences are going to come about. And I think one not a solution, but one thing that people should consider is preparation exercises, whether it's desktop or forming links. So at least people get to sit in the room, understand how their other organisations alongside them work. So when the incident happens, and I guess it's a question of when, not if, across these multiple CNIs, then people at least have an understanding of where they can work together and where there are ongoing things that need to be sorted.
I think within the CNI environment, actually, we often give a very sort of negative perception of this tribal warfare between IT and OT. Actually, since the NIST directive, which was mentioned earlier, there's been a real improvement, from me personally, of that collaboration between groups. There's a common objective to be met. A lot of preparing and planning is in place from the CNI sectors that I see. So there's been a real shift over the last 3 or 4 years in improving the whole situation. So I think we're in a lot better place today than we were 5 or 6 years ago, in actual fact.
Nice, thank you. I've got one over here.
I have a question, so I like the panel's views on that. I see the title, in the title, the word holistic. So a lot of OT domains, certainly in the CNI domains, you would expect that they would have a much more mature culture of an understanding of safety. And the question is, do you think in security we could learn a lot from safety, both in terms of design and architectures, in terms of redundancies and fail safety, and kind of other elements? We were talking about real time earlier on. Once again, there are potential design principles where we could look at to offset some of that immediate, but also the culture element as well, and also the mindset in terms of how we approach security as well, where safety is, well, there are cultural elements, but there is a mindset around it as well. So it'll be useful to just understand, I think, from that perspective, as to what your views are, as to what we can learn from that.
Yeah.
Jeremy wanted to answer.
Yeah, well, I'll start with that. I think it's, as we talked about earlier on, the sort of cultural aspects and actually owning the belief as an enactable thing that you do in the whole of your life. But starting within industry, and one thinks back to my experience of things like FMEA and ALARP type thinking, you know, are those being applied as rigorously within a security mindset as they are in safety or you know, reliability? I'm not sure that they are. So I think there probably is tool development that needs to go on, and there's a space in the academic and probably the commercial marketplace for those tools. That would be my view. But actually getting the embedded belief to be enacted in people, I think, is a subtle thing and needs further examination. Thank you.
I've got one point, because this is I did a bit of work previously in the safety culture piece, working in oil and gas. So I think the big learning from safety culture is not to make the mistake that slips, trips and falls is going to stop major incidents. So we've got a potential issue if in the security culture we go down the let's do patching and everything else will be okay, because that's not the answer. So actually, if you think about the slips, trips and falls scenario that we've had in the past with safety, and it was, if we do all that stuff and you walk up the stairs, if you go to an oil and gas company, you've got to hold the handrail and you can't walk around with a cup of coffee without the lid being on, but we still have major events. That comes down to corporate failure. So not having the correct investment, not having the correct training, not doing things that we should do. There's a whole load of stuff that we can learn from that safety culture piece and bring across to security, and that I think could accelerate the improved position that we're currently in today.
I think there's one other point I just make from my experience in BOC, and that was the culture of looking after your colleagues, not just yourself. So if you see something that could be harming a colleague, then you would report that, do something about it. And I guess that might apply to security as well.
Absolutely.
Yeah.
I think we have time for one more question, just here.
It's about 5 years ago, I went to a Cambridge Wireless event on critical infrastructure, and one of the issues coming up then was we buying new kit for the communications already had firmware with Stuxnet embedded in new equipment and whatever. I mean, are we still suffering that, and what's going on in terms of supply chain validation and all the rest of it for devices and
So I think Bristol University, and I may get this wrong, but they did a study based on when a new piece of software encoded in a PLC or an OT environment is released to the public or the market. I think the number is the 0 day in that, which is being shipped today, has got a gestation of about 5.2 years before it becomes noticed. And that's either noticed by someone who discovers it, there's a friendly notice, or a bad notice by a hostile actor who identifies that 0 day. So that's 5.2 years from a system that's being shipped. And then typically within the OT environment, it takes at least 2 years to make the fix. So we're looking at equipment that's being shipped today within the OT environment that's got vulnerabilities out there, which is, we've got a gap. There's an opportunity for good or bad of 7 years end to end. So the Stuxnet story hasn't really changed in that respect.
Rick, did you want to comment on that?
Unless you're an Iranian nuclear facility, I wouldn't really worry about Stuxnet being involved because it was very specifically targeted. But we're looking now towards software bill of materials, and especially it's very big in the OT kind of area, and I think that's something that would kind of start working towards preventing these kind of things. If you look at historical attacks in operational technology, a number of them have been basically supply chain attacks from state-sponsored adversaries. So they are quite prevalent in the kind of like the whole OT domain. But with software bill of materials and starting to understand exactly what is in everything, so when you get a piece of software or a piece of hardware, what libraries have been used, and exactly what is in this, and everything is itemized, that then presents if there are any anomalies or are any additions that shouldn't have been there in the first place, especially with some of these larger pieces of malware that on a resource-constrained device will actually be taking up like hundreds of megabytes. Like that will all of a sudden be very noticeable.
Yeah, okay.
So,
Thank you.
I was
Yeah.
just going to conclude. So we've heard a lot of scary things there and challenges. But the good news for all of us is we can go away and think of tools and mechanisms to fix all of that. I'd love you to thank our panelists, and I'm going to hand over to Jeremy. Thank you.